Welcome to another video from OptaTube. Today, we're talking about a massive trillion-dollar traffic jam. But here's the thing, it's completely invisible and it's happening right now, right over your head. So what is this mystery traffic jam that's costing us billions every single year? Well, it's not happening on our highways with cars. It's happening in our power lines with electrons. It's a phenomenon called grid congestion. And just like a real traffic jam, it creates huge delays, it wastes incredibly valuable resources, and, you guessed it, it costs all of us a ton of money. Okay, so let's get right into it. What exactly is grid congestion? The easiest way to think about it is to picture the entire power grid as a giant highway system. You've got power plants acting as the on-ramps, and our homes and businesses are all the exits. The transmission lines? Those are the highways themselves. Now this is the crucial part. Congestion happens when the absolute cheapest, most efficient path for electricity is already full. It's at capacity. The grid operator wants to send more of that cheap power down the line, but they literally can't. If they did, it would physically overload the wire, cause it to overheat, and threaten the whole system. So you've got this constant battle between the best economic choice and the hard laws of physics. And it's so important to understand this. Congestion isn't a mistake. It's not a bug in the system. It's a fundamental feature of any physical network that has limits. It doesn't matter if you're moving cars, data, or electrons. You just can't push an infinite amount of something through a finite space. It's just how things work. So why does this happen? Well, first off, you've got physics. Electricity is lazy. It doesn't care about our financial contracts. It just follows the path of least resistance. Second, those paths, the wires, have very strict physical limits. And third, you have the market itself, which is always trying to find the absolute cheapest power, but that perfect plan on paper might physically break the grid in reality. And on top of all that, our best renewable resources, like huge wind farms and massive solar arrays, are usually way out in the middle of nowhere, far from the cities that need the power. That distance creates natural traffic jams. Okay, so this isn't just some abstract problem for engineers to worry about. This gridlock comes with a massive, real-world price tag. And the numbers? They're pretty staggering. To give you an idea of the scale, just look at Germany. In a single year, they spent over 4 billion euros on what are called Redispatch actions. And that's not money for building new lines or upgrading the system. That's just the cost of the emergency, last-minute maneuvers operators have to pull just to keep the lights on when the grid gets clogged. So what does that 4.2 billion euros actually pay for? Well, basically, it's the cost of being inefficient. When a cheap, clean wind farm can't get its power to a city because the line is congested, the grid operator has to tell it to shut down. That's called curtailment. Then, they have to turn around and pay a more expensive and often dirtier power plant closer to the city to fire up instead. And guess who pays for that extra cost? We do. It gets passed directly onto our electricity bills. We are literally paying billions of dollars to waste clean energy. It's wild. So how in the world do grid operators deal with this constant balancing act? Well, there are basically 3 main ways to do it. And they range from, let's say, a clunky manual fix to a really sophisticated data-driven solution. First, you've got Redispatch, which we just talked about. It's really just a Band-Aid, an expensive, inefficient fix that happens outside the market and kind of hides where the real problem is. A step up from that is something called zonal pricing. Here, you split the grid into big regions with different prices. It's better, I guess, but it's a very blunt tool that completely ignores any traffic jams that happen inside one of those big zones. And that brings us to the gold standard, nodal pricing, also known as LMP. This is by far the most efficient, transparent, and accurate way to handle congestion. Now, before we dive into how it works, if you're interested in energy market and power system modeling and you want updates and insights about the global energy market, this is a great time to follow the OptaTube YouTube channel. Okay, let's get into the smartest solution. Nodal pricing, or locational marginal pricing, LMP for short, is considered the best practice for a really simple reason. It makes the price of electricity reflect the physical reality of the grid. See, instead of finding the cheapest power plan first and then scrambling to fix all the traffic jams it creates, an LMP system is way smarter. It does everything at once. It uses these really powerful algorithms that factor in every single physical limit on the grid before it tells a single generator to turn on. The goal is to find the absolute lowest cost to serve everybody, while playing by the rules of physics from the very start. So how does it actually pull this off? Well, you can think of it as a 3-step process. First, the grid operator builds a perfect digital replica, a digital twin, of the entire grid, with all its limits. Second, a powerful algorithm crunches the numbers to find the perfect mix of generation that won't overload any part of the system. And finally, this is the magic part. It assigns a unique, super accurate price to thousands of different points, or nodes on the grid. So a spot right next to a cheap power plant with no traffic will have a really low price. But a town on the other side of a huge bottleneck, it's going to have a much higher price, because that price now transparently includes the cost of that congestion. And that's really the bottom line here. LNP is widely seen as the best practice, especially for the complex, renewable-heavy grids that we're all building today. It takes that invisible problem of congestion and makes it completely visible through clear, honest prices.
And this isn't just some academic debate for wonks and engineers. Choosing the right way to manage the grid is becoming more and more urgent with every passing day.
Let's face it, our grid is going through the biggest change in 100 years. We're adding massive amounts of wind and solar, millions of electric cars plugging in whenever they want, huge batteries, more connections between countries. Every single one of these amazing new technologies adds more stress and a lot more complexity to the grid, which makes congestion an even bigger headache. Trying to manage this complex future grid with an old-school system like Redispatch, it's like trying to manage traffic in a modern city using nothing but stop signs. It just doesn't work. It hides the real problems, it forces us to waste clean energy, and it spreads the cost out so nobody knows who's responsible. A modern approach, like LMP, on the other hand, is like a smart, synchronized traffic light system. It uses price signals to shine a huge spotlight on the bottlenecks. That encourages people to build new lines, or batteries, or other solutions in the exact spots where they're needed the most. That kind of transparency is absolutely fundamental to making the energy transition work and keeping it affordable. And that really brings us to the final critical question. As our entire society gets more and more electric, and as we depend more on a clean, reliable grid, can we really afford to use anything less than the smartest, most efficient solution available? If you're interested in learning more about the energy market and power systems, make sure to follow the OptaTube YouTube channel for more explainers just like this one.